March 14, 1945. In the shattered suburbs of Vienna, a Soviet tank commander named Dmitriy Leza watched his Sherman tank crew perform maintenance that would have taken a T-34 crew twice as long. The American-built M4A2 diesel Sherman had carried his Guards mechanized unit through the Carpathians, across Hungary, and now stood before the last stronghold of the Reich. His gunner cleaned the 76mm gun's optics using the built-in auxiliary power unit to keep the batteries charged, a luxury Soviet tankers had never known. 500 kilometers to the east, in the Ural factory complex known as Tankergrad, Soviet engineers stared at disassembled Sherman components spread across workshop tables. They had studied every bolt, every weld, every cleverly standardized part. They understood the automotive precision that made American tanks legendary for reliability. They grasped the assembly line efficiency that allowed Detroit factories to produce Sherman. Tanks faster than Chelyabinsk could produce T-34 seconds despite having more workers and running longer shifts. Yet, when they tried to replicate what they saw, something essential vanished in translation. This is the story of how Soviet industry learned to copy American engineering but could never match American production. How the nation that fielded 84,000 T-34 tanks discovered that quantity and quality represented two different victories. How the engineers of Tankograd came to understand that building a tank and building a tank well required more than blueprints and political will. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. The paradox began in the 1920s and 30s, when Soviet industrial planners didn't just admire American manufacturing, they hired Americans to build it for them. The famous architect Albert Kahn, who had designed Ford's Highland Park plant and pioneered the modern assembly line factory, personally designed the Stalingrad tractor plant. American engineers from Detroit supervised the construction of production lines across the Soviet Union. Tool manufacturers from Pittsburgh installed machinery in factories from Leningrad to Kharkov. The Soviets weren't merely inspired by American mass production, they literally purchased it, imported it, installed it. The Chelyabinsk tractor plant, founded in 1933, embodied this American-Soviet industrial marriage. Its first product, the S-60 tracked tractor, was an almost direct copy of the American Caterpillar 60. The technology, the layout, the production philosophy, all American in origin. By 1940, Chelyabinsk had produced 100,000 tractors using methods borrowed wholesale from Detroit's automotive industry. When war came in June 1941, this American-influenced industrial base became the Soviet Union's salvation. As German forces captured or threatened every major industrial city west of Moscow, Stalin ordered the greatest industrial evacuation in history. 7 major factories, including most of Leningrad's Kirov plant with 15,000 workers, relocated to Chelyabinsk. Machine tools traveled east on trains while German artillery shells fell behind them. Workers reassembled production lines in open air, sometimes in -20-degree temperatures, as buildings rose around them. The renamed complex Chelyabinsk Kirov Plant No. 100, but universally known as Tankergrad, became the beating heart of Soviet armored vehicle production. By 1944, 60,000 workers labored there, producing 18,000 tanks and self-propelled guns, 48,000 tank diesel engines, 17 million ammunition units. The numbers seemed miraculous. Soviet propaganda celebrated Tankergrad as proof of socialist industrial superiority, but the men who actually built these tanks knew a darker truth. Major General N. Fedorenko, head of the Armored Directorate of the Red Army, maintained careful records that contradicted the triumphant public narrative. His reports documented a catastrophe hidden behind production statistics. In 1942, preliminary inspections at the Ural Tank Factory, No. 183, the largest T-34 producer, showed that only 7% of newly built tanks were free of significant defects. 7%. 93 tanks out of every 100 rolled off the assembly line with problems serious enough to be immediately documented. The following year, 1943, that figure improved to 14% defect-free. Still, 86 of every 100 new T-34 seconds had major flaws at delivery. By 1944, quality had risen to 29.4%, passing initial inspection without serious problems. An improvement, certainly. But it meant that even late in the war, 7 of every 10 Soviet tanks left the factory already compromised. Fedorenko's office conducted systematic reliability trials throughout the war. In April 1943, they randomly selected newly completed T-34 seconds and subjected them to a 330-kilometer endurance test, barely 200 miles. Only 10.1% completed the trial without breakdown. These weren't propaganda statistics intended for Western consumption. These were internal Red Army documents, written by Soviet officers, assessing Soviet equipment for Soviet commanders. The average T-34, according to Fedorenko's official assessment, required major overhaul after covering less than 200 kilometers. That's 124 miles. Many T-34 seconds consumed their entire first tank of diesel without the engine surviving long enough to require refueling. The transmission became infamous among T-34 crews. The gearbox, crudely manufactured and inadequately hardened, self-destructed with regularity. Loaders kept sledgehammers handy not as weapons, but as tools to force jammed gears when the transmission froze. Many experienced crews strapped spare transmissions to the rear hull, knowing they'd need them long before the tank saw serious combat. The sight of a T-34 carrying its own replacement transmission became so common that photographs showing this arrangement appear throughout the historical record. Engine problems plagued every model. The V234 diesel engine, in theory a robust design superior to gasoline engines, suffered from air filters that allowed dust and sand through unimpeded. The filters were redesigned multiple times, but production pressures meant many tanks received old specification filters simply because those were what the factory had in stock. Engines choked on the fine dust of Ukrainian fields, ground themselves apart with particulates that American or German filters would have stopped. Steering clutches overheated during any sustained maneuvering. German after-action reports from captured T-34 seconds noted that the clutches, stressed by combat conditions or difficult terrain, coated themselves with oil from overheating. Once oil-soaked, they lost grip. The tank became immobile, steerable only after cooling and cleaning procedures impossible under fire. The turret's electrical traverse mechanism sparked dramatically, burning out speed regulators and shattering gear teeth. Many crews simply disconnected the powered traverse and rotated their turrets manually, using brute strength to track targets. Tracks, made from inadequately hardened steel, snapped under stress, not occasionally, regularly. Crews carried spare track sections the way infantrymen carried extra ammunition, essential consumables that would certainly be needed. The counter-offensive following Stalingrad in winter 1942 to 1943 has entered legend as the moment the T-34 achieved mythical status. Soviet propaganda presented it as unstoppable masses of superior tanks crushing German resistance. Documents released after the Soviet Union's collapse revealed a different reality. In just 6 days of fighting, Russian tank brigades lost 326 tanks out of 400 engaged. The Germans claimed to have destroyed 66 T-34 seconds in combat. Where did the other 260 tanks go? Mechanical breakdown. 260 Soviet tanks, 65% of the force, became casualties not to German guns, but to their own failing components. The transmission that finally quit, the engine that seized, the suspension that collapsed, the clutch that fused. Soviet tankers joked bitterly that their life expectancy was measured not in combat hours, but in kilometers traveled to reach combat. Entire brigades lost 30 to 50% of their strength, simply marching to the battlefield. On February 4, 1944, the 21st Guards Tank Brigade received orders to proceed 80 kilometers by road to Tolstoye Rogi. 32 T-34 seconds began the march. 19 became stuck in mud or suffered mechanical failures before reaching their destination. 60% losses on an 80-kilometer march over roads in a brigade of supposedly elite guards units operating supposedly battle-tested equipment. The Soviets kept building them anyway, because they had no choice. If you're finding this deep dive into wartime engineering fascinating, please hit the like button and share this video with anyone who appreciates untold history. Your support helps us create more content like this. Soviet strategic doctrine required masses of armor for deep penetration operations. The Red Army needed thousands of tanks regardless of quality. Stopping production to fix systemic problems would leave divisions without armor for months. Better to field tanks that might fail than to field no tanks at all. The grim calculation became explicit in tank unit replacement schedules. The average thermos T-34 survived less than 6 months at the front before destruction or irreparable breakdown. The Soviets simply built replacements faster than tanks could be lost. Crews were even more expendable. Young men received abbreviated training and reported to units that treated them as temporary occupants of machines that would outlast them. Usually, the machines didn't outlast the crews. Both died together. American tankers who examined captured T-34 seconds were baffled by what they found. The U.S. Army shipped a T-34, built at the best Soviet factory using highest quality materials, to Aberdeen Proving Ground in Maryland for evaluation in 1943. Soviet engineer Matveyev personally supervised its maintenance, ensuring it received care no frontline T-34 would ever see. The engine failed after 72.5 hours of operation. A Soviet mechanic maintaining a hand-selected example running in ideal conditions couldn't keep it functional for 3 full days of operation. American engineers wrote detailed assessments noting the paradox. The T-34's fundamental design impressed them. Sloped armor, wide tracks for superb flotation, powerful gun, diesel engine, all sound choices representing advanced thinking about armored warfare. But the execution horrified them. Russians, when producing tanks, pay little attention to careful machining or the finishing and technology of small parts and components, the Aberdeen report concluded, which leads to the loss of the advantage which would otherwise accrue from what on the whole are well-designed tanks. They elaborated. The turret was cramped to the point of dysfunction. American evaluators couldn't understand how Soviet tankers wearing winter sheepskin jackets could physically fit inside. The 2-man turret arrangement meant the commander also served as gunner, an inefficient compromise that German and American 3-man turrets had abandoned years earlier. Vision devices were crude, gun sights were imprecise. The radio, if the tank even had one, since only command tanks received radios, was unreliable. Most damning, Russian tanks are significantly inferior to American tanks in their simplicity of driving, maneuverability, the strength of firing, speed, the reliability of mechanical construction, and the ease of keeping them running. This wasn't German propaganda. This was the assessment of America's allies, written by engineers who wanted to help the Soviets improve their tanks. The Soviets already knew. Their own reports said the same things, often in harsher language. Why couldn't they fix it? The answer lay in the fundamental difference between copying a design and replicating a production system. Soviet engineers at Grad understood American automotive manufacturing in theory. They'd studied Ford's assembly line principles. They'd toured American tank factories. They possessed detailed technical drawings of American components. When Lend-Lease Sherman tanks began arriving in 1942, Soviet technical teams disassembled them completely, measuring every part, analyzing every manufacturing technique. What they discovered was that the Sherman represented not simply a tank design, but the culmination of 40 years of American automotive industrial development. The M4 Sherman emerged from a manufacturing culture that treated quality control as fundamental, not optional. Detroit automakers had spent decades perfecting precision machining, heat treatment of steel, bearing manufacture, gear cutting, quality assurance procedures. These weren't secrets. They weren't even particularly exotic techniques. They were simply standards. Standards that required specific machine tools, specific metallurgical processes. specific quality control systems, specific workforce training. Each Sherman component met tolerance specifications measured in thousandths of an inch, gears meshed precisely, bearings seated evenly. Tolerances allowed parts from different factories to interchange perfectly. An M4A3 transmission built in Detroit fit without modification into an M4A1 hull built in Ohio. Spare parts from depot stock matched original equipment exactly. This standardization meant Sherman tanks could be maintained by crews with modest training using common tools. Break a gear, install a replacement, burn out a starter motor, swap in a new one. The modularity wasn't magical. It was engineering discipline applied across thousands of components and dozens of factories. Soviet production achieved nothing comparable. Tankergrad's machine tools, worn by years of constant operation and inadequate maintenance, couldn't hold the tolerances American factories considered routine. Two T-34 transmissions from the same production run might have gears differing by millimeters, small variances with catastrophic effects on lifespan and reliability. Ball bearings, supposed to be precisely spherical, came out slightly elliptical. Such bearings worked, briefly, then they failed. Heat treatment of steel requires precise temperature control and specific cooling rates. American factories used sophisticated furnaces with thermostatic controls. Soviet factories, pressed for time and often operating with damaged or improvised equipment, heat-treated in batches using whatever furnaces were available. Sometimes the steel hardened too much, becoming brittle and prone to cracking. Sometimes it didn't harden enough, wearing rapidly under stress. T-34 armor plate became infamous for quality variation. Some plates, properly hardened, provided excellent protection. Others, inadequately hardened or hardened inconsistently, developed a spalling problem that American metallurgists identified immediately. When an armor-piercing round struck the plate without penetrating, the impact's kinetic energy could shatter the inner surface. Fragments of the tank's own armor sprayed through the crew compartment like shrapnel. The crew died from their own tanks. Metallurgical defects. American metallurgical analysis revealed that T-34 armor steel received inconsistent rolling treatment. Modern rolled armor requires numerous passes through mills at controlled temperatures, creating a steel plate with specific grain structure. Soviet armor, examined under microscope, showed irregular grain structure suggesting rushed rolling processes with inadequate temperature control. Soviet factories weren't incompetent. They were desperate. The workers at Tankergrad weren't lazy. They labored 12-hour shifts, often 16-hour shifts, 7 days per week, in factories where winter temperatures inside sometimes matched the -30 degrees outside. Women who'd never seen a machine tool learned to operate lathes and milling machines in week-long training courses. Teenagers, fresh from collective farms, assembled transmissions they barely understood. Experienced machinists who'd survived the evacuation from Kharkov or Leningrad worked until they collapsed, then returned the next day to continue. The production quotas came from Moscow, set by officials who knew the Red Army's desperate need but didn't grasp industrial reality. Meet the quota or face consequences that ranged from dismissal to arrest to execution. Factory managers falsified quality control reports, shipping tanks they knew were defective rather than admit shortfalls. Quality inspectors, themselves facing quotas for approval rates, passed tanks that clearly failed specifications. Everyone involved understood the bargain. Field defective tanks or field no tanks. At the Stalingrad tractor factory, as German artillery fell on the city in 1942, workers assembled T-34 seconds in one workshop, while German infantry fought Soviet defenders in another section of the same building. Tanks rolled directly from the assembly line into combat hundreds of meters away. Many lacked gun sights. Some lacked radios. A few lacked driver's seats. The driver folded his greatcoat to sit on. They were painted in bare metal or covered only in primer. Their acceptance tests consisted of successfully starting the engine and moving under power to the front gate. These tanks bought time. Soviet defenders held Stalingrad. The Red Army stabilized the front. but the Stalingrad factory fell to German forces in September 1942. By then, the Ural factories had reached full production, and the Americans had begun sending Sherman tanks across the Arctic Ocean. The first American M4A2 Sherman tanks reached Soviet ports in late 1942. Soviet tankers initially regarded them with suspicion. American technology was unfamiliar. The gasoline-powered M4A4 variant, demonstrated to a Soviet technical delegation at Chrysler's Detroit tank arsenal, had been rejected as inferior to the diesel M4A2 the Soviets were already receiving. Soviet crews expected these Lend-Lease tanks to be stopgaps at best, inferior to their own T-34 seconds. Then they started using them in combat. Dmitry Leza, who would rise to hero of the Soviet Union commanding Sherman tanks, described his first encounter with the M4A2 in his post-war memoir. The reliability astonished him immediately. The Sherman's General Motors diesel engine, not so different in concept from Soviet diesel engines, simply worked. It started reliably in cold weather. It ran without consuming oil. It reached its 200-hour maintenance interval and continued running. Crews familiar with T-34 seconds, where engines often failed before reaching 100 operational hours, found themselves commanding tanks that operated for 3, 4, 500 hours between major overhauls. The transmission shifted smoothly using a conventional automotive gearbox. No sledgehammers required. Gears engaged cleanly. The clutch functioned properly. American automotive precision meant components wore slowly and predictably, rather than failing catastrophically without warning. The auxiliary power unit became legendary among Soviet tankers. This small gasoline engine, mounted separately from the main power plant, charged the batteries without running the main diesel. American tankers took this feature for granted. Soviet tankers, accustomed to T-34 seconds where the main engine ran constantly to keep batteries charged, recognized it as transformative. A Sherman tank could sit in ambush for hours, with all systems powered, batteries charging, without giving away its position with engine noise. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The fighting compartment's ergonomics stunned crews. The turret basket, absent from Soviet designs, provided a platform that rotated with the turret, keeping the crew stable and surrounded by ready ammunition. American tanks had 5-man crews: commander, gunner, loader, driver, bow gunner. Each man had a specific job. The commander commanded, observing the battlefield, and directing the crew. The gunner aimed. The loader loaded. Nobody performed double duties. Soviet 2-man turrets, where the commander also gunned, couldn't match this efficiency. Vision devices in the Sherman were superb by Soviet standards. American tankers complained about inadequate vision blocks, but compared to T-34 viewports, the Sherman offered panoramic luxury. The commander's cupola provided all-around observation. Periscopes gave actual visibility. Optical quality was exceptional. American glass manufacturing standards produced lenses that Soviet optics couldn't match. Most tellingly, the Sherman's armor didn't spall. When German anti-tank rounds struck without penetrating, the interior remained safe. American steel rolling processes and heat treatment created armor plate that absorbed kinetic energy without fragmenting inward. Soviet tankers, who'd watched crewmen killed by their own tank's shattered armor, found this almost miraculous. Soviet Guards units elite. Formations receiving the best equipment began requesting Shermans specifically. The 1st Guards Mechanized Corps, 3rd Guards Mechanized Corps, 6th Guards Tank Army, 9th Guards Mechanized Corps all standardized on American M4A2 tanks. These weren't rear echelon parade units. These were formations at the cutting edge of Soviet offensive operations, units that would spearhead the drive into Germany itself. When given a choice between T-34 seconds and Shermans, elite Soviet tankers increasingly chose Shermans. The Soviet technical evaluation of the M4A2, submitted to Stalin and forwarded to Roosevelt, praised the American tank extensively. The reliability impressed evaluators most. Despite our expectations, the report noted, the American tank demonstrates excellent mechanical durability. The report praised the turret layout, the crew comfort, the vision devices, the auxiliary power, the radio equipment items. Simply calling every radio-equipped tank Sherman became standard. However, the evaluation also noted perceived weaknesses. The Sherman was taller than the T-34, presenting a larger target profile. Its higher center of gravity made it more prone to rolling over on rough terrain or during collisions, a significant issue given Soviet tactical doctrine favoring aggressive cross-country maneuver. The 75mm gun, while adequate, didn't match the penetration of German long-barreled weapons appearing in 1943 and 44. But these criticisms appeared alongside unmistakable recognition. The Sherman represented a different standard of automotive engineering. It wasn't simply designed better, it was built better. Every component reflected manufacturing precision that Soviet industry couldn't replicate. Soviet engineers at Grad disassembled Sherman tanks and studied every manufacturing detail. They found welds executed with consistent quality. They found castings with uniform properties. They found machined surfaces, finished to exacting specifications. They found gears with teeth cut to tolerances measured in 10,000ths of an inch. They found bearings manufactured to standards requiring specialized equipment Soviet factories didn't possess. They understood what they were seeing. They grasped the principles. They recognized the techniques. They couldn't reproduce them. Not because they lacked intelligence or dedication, but because they lacked the accumulated industrial infrastructure, the machine tools, the quality control systems, the trained workforce, the cultural expectation of precision that made Sherman quality production possible. The contrast became brutally apparent to those who experienced both tanks firsthand. In 1944, after the Kishinev operation, a Soviet mechanized corps received a mixture of T-34 85 seconds and Sherman M4A2 76mm tanks. Same crews, same training, same combat conditions, two different machines. The maintenance logs told a stark story. The Shermans logged an average of 195 to 205 operational hours before requiring major overhaul. The T-34 seconds, even the improved 85mm gun models with enhanced reliability, averaged 185 to 190 hours. On paper, a modest difference. In practice, it meant Sherman-equipped units maintained higher operational readiness, more tanks available for each mission. Fewer breakdowns during approaches to combat, fewer tanks abandoned with seized engines or broken transmissions. Soviet tank commander interviews collected after the war reveal the psychological impact of this reliability gap. With the T-34, you always worried, one veteran recalled. Would the transmission last? Would the engine overheat? You carried spare parts like a soldier carries ammunition because you knew you'd need them. With the Emcha, the Soviet nickname for the Sherman, derived from M4, you worried about Germans, not your own tank. That confidence changed everything. The nickname itself revealed Soviet attitudes. Emcha carried no negative connotation. Contrast this with the bitter sarcasm Soviet soldiers applied to the British Matilda tank, unbelievably worthless, or the M3 Lee, which they called coffin for 7 brothers. The Sherman earned genuine respect from men who had every reason to prefer their own nation's equipment for propaganda purposes. By 1945, over 4,000 Sherman tanks had reached Soviet forces. Some elite units operated Shermans exclusively. These tanks spearheaded the final offensives through Eastern Europe. They rolled into Vienna, into Prague, into Berlin itself. Photographs from the war's end show Sherman tanks with Soviet markings parked before the Reichstag, their American-built diesel engines still running reliably after campaigns that would have consumed multiple T-34 seconds. Yet Soviet propaganda after the war systematically minimized this contribution. Official histories claimed Lend-Lease provided only 12% of Soviet aircraft, 10% of tanks, 2% of artillery. These figures deliberately excluded 1944 and 45 deliveries, the period when Lend-Lease reached its peak. The full accounting, including all war years, shows America provided over $11 billion of equipment to the Soviet Union, roughly $250 billion in today's currency. More importantly than raw numbers, American trucks over 500,000 vehicles provided mobility Soviet industry couldn't supply. Soviet factories produced only 343,000 trucks during the entire war because automotive production had been converted to tank production. American trucks moved Soviet tanks to the front. American locomotives pulled Soviet trains. American aviation fuel powered Soviet aircraft. American communications equipment coordinated Soviet operations. The contribution was so comprehensive that Stalin himself privately acknowledged it, telling colleagues in 1943, "Without American production, we would have lost the war." Yet publicly, both during and after the conflict, Soviet leadership downplayed American aid to the point of denial. Cold War politics demanded the narrative that Soviet arms defeated Germany through Soviet strength alone. This political requirement extended to tank production. Soviet industry had built more tanks than any other nation, 84,000 T-34 seconds alone. The United States built 49,000 Shermans. In the simplistic mathematics of wartime propaganda, more tanks meant better industrial performance. Soviet publicists celebrated Tankograd's output while ignoring the quality crisis documented in Soviet military's own internal reports. But the engineers at Tankograd knew better. They had disassembled Shermans. They understood what American production achieved that Soviet production couldn't match. The question haunted them. Why? What made the difference? The answer lay not in any single factor, but in accumulated layers of industrial culture. American automotive manufacturing in 1944 represented 50 years of continuous refinement. Henry Ford's moving assembly line, introduced in 1913, had revolutionized production, but the assembly line itself was merely the visible manifestation of deeper principles. Standardization, interchangeability, quality control, statistical process control, preventive maintenance, continuous improvement. These weren't slogans. They were practiced disciplines embedded in American industrial culture. Workers in Detroit's tank plants were often former automotive workers, men and women who'd spent years building cars to exacting specifications. They understood that a transmission assembled carelessly would fail prematurely. They knew that skipping a quality check saved minutes but cost hours later in warranty repairs. They brought automotive industry standards to tank production because those standards were what they knew. American machine tools represented cutting-edge precision. Companies like Brown and Sharp, Cincinnati Milling Machine, and Warner and Swazi produced equipment capable of holding tolerances measured in 10,000ths of an inch, repeatedly, reliably. These machines required skilled maintenance, but American factories had mechanics trained specifically in machine tool maintenance. The tools stayed accurate because accuracy mattered. American steel mills supplied tank factories with rolled armor plate meeting specifications that Soviet mills struggled to match. American metallurgical science had developed advanced alloys and heat treatment processes through decades of research and industrial application. The steel that went into Sherman armor wasn't magically better. It was consistently better, meeting specifications batch after batch, because American quality control caught deviations and corrected them. The first American workforce, though expanded rapidly during wartime, drew on a population with higher average education and broader industrial experience than Soviet workers. A Michigan farm boy who'd grown up repairing tractors arrived at tank factories with mechanical intuition that a Ukrainian collective farmer sent to Tankograd simply hadn't developed. American workers could read technical drawings, use precision measuring instruments, understand why specifications mattered. Most fundamentally, American factories operated without the existential terror that pervaded Soviet industry. An American quality inspector who rejected defective work faced no consequences beyond possible argument with a foreman. A Soviet quality inspector who rejected too many tanks risked investigation for sabotage. American managers who reported production problems received help solving them. Soviet managers who reported production problems risked arrest for failing to meet quotas. This cultural difference created a feedback loop. American factories identified problems and fixed them, improving quality over time. Soviet factories hid problems and shipped defective products, perpetuating quality issues indefinitely. Both systems produced large numbers of tanks. Only one produced consistently reliable tanks. Soviet engineers understood this distinction intellectually. Some even dared to write carefully worded reports suggesting changes to production processes, better quality control, improved worker training. These reports vanished into bureaucratic channels, emerging occasionally as directives that factories ignored because meeting quantity quotas took absolute precedence. The mathematical brutality was inescapable. Soviet production outpaced American production in raw tank numbers. 84,000 T-34 seconds versus 49,000 Shermans, but 44,900 T-34 seconds were lost during the war, 82% of total production. Many historians estimate that 40% of these losses resulted from mechanical or logistical failures rather than German action. The implications staggered anyone who thought through them carefully. Soviet industry built vast numbers of tanks that broke down before seeing combat, or failed during combat at rates far exceeding American equipment, or simply never reached their operational lifespan potential. The resource investment per combat effective tank hour was catastrophically inefficient compared to American production. If Soviet factories had produced 49,000 T-34 seconds built to Sherman reliability standards, they might have achieved equivalent battlefield effectiveness to the 84,000 actually produced. The difference, 35,000 tanks, millions of man-hours, vast quantities of scarce steel and fuel, represented waste on a scale that even Stalin's regime couldn't acknowledge publicly. Privately, Soviet leadership recognized the problem. In December 1943, Stalin signed an order extending the official service life guarantee of T-34 engines from 200 hours to 250 hours, a 25% improvement achieved through directive rather than engineering. The Second Guards Tank Army reported in February 1945 that actual average T-34 engine life was 185 to 190 hours, a 30% below the official guarantee issued more than a year earlier. The order hadn't fixed anything. It had simply changed what the army claimed to guarantee. This pattern, declaring problems solved through administrative fiat, while actual problems persisted, characterized Soviet industrial culture throughout the war. Production numbers increased because Stalin ordered them to increase. Quality improved because reports claimed improvement. Reality, documented in maintenance logs and after-action reports that circulated only among military logistics officers, told different stories. The German army, fighting both T-34 seconds and Shermans on different fronts, formed clear opinions about relative quality. German tank crews preferred capturing T-34 seconds over Shermans, not because Soviet tanks were better, but because they were more likely to need only minor repairs to become operational. Shermans captured from Americans or British typically required more sophisticated repairs beyond German field capabilities. T-34 seconds often needed only fuel, ammunition, and basic mechanical work because they'd been abandoned due to mechanical problems rather than battle damage. German maintenance manuals for captured Soviet equipment included extensive sections on common T-34 failures: clutch overheating, transmission jamming, track breakage, air filter inadequacy. The manuals for captured Shermans focused primarily on ammunition supply and operational employment rather than mechanical problems, because Shermans generally didn't have chronic mechanical problems. This German perspective validated what Soviet tankers experienced daily but couldn't openly discuss. Their tanks were mechanically inferior to Western designs, not because Soviet engineers were incompetent, but because Soviet production systems couldn't match Western manufacturing standards. The knowledge sat like lead in the stomachs of Tankograd's engineers. They were producing inferior equipment. They knew it. They couldn't fix it. Political requirements demanded they pretend the problem didn't exist while quietly trying to improve quality within constraints that made real improvement nearly impossible. Some improvements did occur. By 1944, T-34 reliability had genuinely increased compared to 1942's disaster. The evacuation chaos had settled. Workers had gained experience. Production processes had been refined through hard-won trial and error. The T-3485 model, introduced in 1944, incorporated multiple improvements: better transmission, improved clutch, stronger suspension, three-man turret. These changes made real differences, but improved still meant fundamentally inadequate by American standards. The T-3485 represented the best Soviet industry could produce under wartime conditions. It remained crude compared to American equipment, prone to failures that Sherman tanks rarely experienced, demanding constant maintenance that American tanks didn't require. Soviet tankers who transitioned from Shermans to T-34 a rare but documented occurrence when Lend-Lease supplies couldn't meet demand universally, regarded it as a downgrade. One veteran recalled, "Going from the MK to the T-34 felt like moving from a comfortable house to a poorly built shack. Everything about the Soviet tank was harder, rougher, less reliable. We did our jobs, but we missed the American machines." The post-war period brought its own ironies. In 1945 and 46, Stalin ordered all surviving Lend-Lease Sherman tanks either returned to American control or destroyed. The ostensible reason was contractual. Lend-Lease terms required return or payment for equipment after the war ended. The actual reason was political. Stalin wanted no visible evidence of Western contributions to Soviet victory. Many Shermans were converted to civilian use, their turrets removed and chassis adapted as tractors or construction equipment. Some were cut up for scrap. A few survived in museums, their Lend-Lease origins carefully obscured in exhibit descriptions. By the 1950s, Soviet historical narratives had effectively erased the Sherman's role in the Great Patriotic War. New generations of Soviet citizens grew up believing the T-34 alone had won the tank war in the East. The engineers who knew better stayed quiet. Speaking honestly about Western technical superiority was politically dangerous throughout the Cold War. But the knowledge remained, preserved in technical libraries and classified reports, a truth too uncomfortable to acknowledge but too obvious to deny. The Korean War provided unexpected validation. In June 1950, North Korean T-3485 spearheaded the invasion of South Korea. American M4, A-3 Shermans, supposedly obsolete compared to the newer Soviet design, engaged them in the first tank-versus-tank combat of the conflict. The results surprised observers who'd accepted Soviet claims of T-34 superiority. American Shermans, even the older 76mm gun versions, consistently defeated T-3485 in combat. Not through superior armor or firepower, the tanks were roughly equivalent in those categories. American tankers won through better optics, better crew ergonomics, better situational awareness, better mechanical reliability. American tanks fought at full capability because they worked properly. Soviet-built tanks fought at reduced capability because mechanical problems degraded their performance even when they remained operational. 119 tank-versus-tank engagements occurred between American and North Korean forces during the Korean War. American forces destroyed 97 T-3485 with another 18 probable kills. American losses were somewhat higher, but considering that the United States was fighting with 5-year-old Shermans against newer Soviet designs, the results spoke volumes about relative quality. Chinese and Soviet advisors, analyzing these battles, privately acknowledged what they couldn't publicly admit. American tanks worked better because American industrial processes produced better tanks. The T-34's theoretical design advantages disappeared when actual manufacturing quality was considered. This realization influenced Soviet post-war tank development. The T-54, introduced in 1947, and subsequent designs incorporated lessons learned not from Soviet production experience, but from studying American equipment. Better optics, better crew layout, better quality control standards, better manufacturing processes. Soviet industry slowly, painfully, began implementing standards that American industry had practiced for decades. But the gap persisted. Throughout the Cold War, Soviet armored vehicles maintained a reputation for crude construction, poor ergonomics, and mechanical unreliability compared to Western designs. Soviet engineers continuously studied captured Western equipment, trying to understand not just what was built, but how it was built to such consistent standards. The answer they kept finding was the same answer Tankograd's engineers had found in 1943. American quality wasn't a design feature that could be copied. It was a cultural product of 50 years of industrial development, embedded in machine tools and worker training and management philosophy and quality control systems. You couldn't copy American production by copying American tanks. You had to copy American industrial culture, and culture couldn't be copied from blueprints. The irony deepened when historians examined Lend-Lease statistics carefully. The 4,000 Shermans America sent to the Soviet Union represented about 8% of Soviet tank strength at the war's end. But these tanks equipped Guards units spearheading critical offensives. Their mechanical reliability meant they were available for operations at rates far exceeding T-34 seconds. A Sherman that ran for 400 hours before major overhaul provided twice the operational availability of a T-34 that required overhaul after 200 hours. 8% of tanks by number might have provided 15 or 20% of actual combat capability. This calculation never appeared in Soviet publications. It remained the kind of uncomfortable truth that classified reports documented but official histories ignored. The Soviet Union had needed American tanks because Soviet tanks, despite impressive design and massive production numbers, couldn't reliably perform their missions. Dmitriy Leza, retiring after the war as a hero of the Soviet Union, wrote his memoirs decades later, when political conditions permitted limited honesty. His assessment of American versus Soviet equipment was diplomatic but clear. The Sherman was an excellent tank for the conditions in which we fought. Its reliability was outstanding. Its crew comfort was superior. Its maintenance requirements were reasonable. We accomplished our missions because our equipment worked when we needed it to work. Reading between carefully chosen words, Soviet equipment often didn't work when needed. That failure cost lives, cost time, cost strategic opportunities. The Sherman's greatest contribution to Soviet victory wasn't its armor or its gun. It was that it worked. The engineers at Tankograd never received recognition for their understanding of this fundamental truth. They spent the war producing tanks they knew were inferior, unable to implement the changes that would have made them competitive, watching as political requirements and production quotas prevented the industrial reforms that might have closed the quality gap. Their achievement was producing 84,000 tanks under impossible conditions, with inadequate tools and desperate timelines. That accomplishment helped win the war, but they understood better than propagandists, better than historians, better than politicians that winning through quantity rather than quality represented a failure of industrial capability, not a triumph. The comparison between Tankograd and Detroit embodied a larger comparison between Soviet and American industrial cultures. Both systems produced impressive quantities, both mobilized vast workforces, both contributed decisively to Allied victory, but one system produced consistent quality, while the other struggled to produce adequate quality even under wartime pressure. This difference wasn't about intelligence or dedication. Soviet engineers were brilliant. Soviet workers were devoted. Soviet sacrifice exceeded anything American citizens experienced. The difference was infrastructure, the accumulated industrial capacity, quality control, culture, manufacturing precision, and production philosophy that America had developed over 50 years and the Soviet Union tried to replicate in less than 10. You can't build that infrastructure with blueprints. You can't decree it into existence with production quotas. You can't copy it by studying foreign equipment. Industrial culture grows slowly, through generations of workers learning standards and managers valuing quality and engineers solving problems and companies competing to produce the best products. The Soviet Union tried to short-circuit this process through sheer force of will. They succeeded in producing vast quantities. They failed to match Western quality. The T-34 became legend because Soviet propaganda needed a symbol of technological triumph. The reality, documented in maintenance reports, reliability trials, battlefield performance comparisons, and veteran testimonies, was more complex and less flattering. In March 1945, as Dmitry Leza's Sherman Tank Company prepared for the final assault on Vienna, he inspected his vehicles and marveled again at their condition. After months of continuous operations, hundreds of kilometers of movement, dozens of engagements, his tanks remained mechanically sound. Engines ran smoothly, transmissions shifted cleanly, suspensions functioned properly. These American-built machines, shipped across the Arctic Ocean and driven across Eastern Europe, worked as designed. Soviet propaganda would later claim the T-34 won the war in the East. Leza knew better. The T-34 helped win the war through sheer numbers, through the courage of crews who fought in unreliable machines, through the sacrifice of tankers who died when mechanical failures left them stranded under German guns. But the tanks that worked best, the tanks that elite Soviet units requested by name, the tanks that spearheaded the final offensives into the Third Reich's heart, those were the Shermans. American engineering, American production quality, American industrial culture on tracks, proving day after day that quantity and quality were different measures of success. The engineers at Grad had copied American designs. They'd studied American techniques. They'd tried to replicate American methods. But they couldn't copy American industrial culture, the invisible foundation beneath American production success. That culture, built over decades through continuous refinement of processes and standards, represented America's true contribution to Allied victory. Not just tanks and trucks and aircraft, though those certainly mattered. The deeper contribution was proof that industrial systems designed around quality, reliability, and worker capability could outproduce systems designed around quotas, regardless of how many workers or how many factories those quota-driven systems commanded. I learned this lesson but could never publicly acknowledge it. American technical superiority threatened Soviet claims of socialist industrial triumph. So the narrative became that Soviet quantity defeated German quality, ignoring the awkward reality that American quality defeated both German technological sophistication and Soviet numerical superiority. The truth remained buried in classified reports and veteran memories and maintenance logs that contradicted official histories. The T-34 was an adequate tank produced in vast numbers under desperate conditions by a nation that couldn't afford to produce excellent tanks. The Sherman was an excellent tank produced in large numbers by a nation whose industrial culture valued excellence as much as quantity. Soviet engineers tried to copy the Sherman. They succeeded in understanding it. They failed to replicate the manufacturing culture that made it possible. That failure, more than any battle or campaign, illustrated the unbridgeable gap between American and Soviet industrial capabilities during World War II. 80 years later, military historians still debate whether the T-34 or the Sherman was the better tank. The engineers who actually built them, who examined both designs in minute detail, who understood the manufacturing processes behind each vehicle, knew the answer. Quality isn't something you copy from blueprints. It's something you build into your industrial culture, piece by piece, standard by standard, generation by generation. The Soviet Union tried to compress that generational development into wartime emergency production. They succeeded in producing tanks that were good enough to win. They failed to produce tanks that worked as well as American tanks worked. That failure, that gap between aspiration and achievement, was written in transmission failures and engine seizures and reliability trials that 90% of new tanks couldn't complete. Grad produced 18,000 fighting vehicles during the war. That achievement deserves recognition, but the engineers there knew, as they watched Sherman tanks arrive through Lend-Lease, that American factories had accomplished something Soviet industry couldn't match, building tanks that actually worked the way tanks were supposed to work, consistently, reliably, repeatedly. You couldn't copy that. You could only envy it. The industrial archaeology of this failure reveals itself in unexpected places. In 1943, the U.S. War Department agreed to send a technical delegation to observe Soviet tank production firsthand. The Americans who visited Tankergrad returned with reports that oscillated between admiration and horror. They admired the scale: 60,000 workers laboring in a facility that sprawled across hundreds of acres, assembly lines moving with relentless rhythm, raw steel entering one end of the complex, finished tanks emerging from the other. The Americans recognized the template this was Ford's. Highland Park plant reimagined for armored warfare. The assembly line principle applied to military production on a scale unprecedented in history. But the details revealed fundamental differences. American visitors watched Soviet welders working on hull sections and noticed immediately that the welds varied dramatically in quality. Some were excellent, executed by skilled workers who understood metallurgy and technique. Others were crude, barely adequate, performed by teenagers who'd received days of training rather than months. The American standard, consistent quality across all welds, simply didn't exist. Each hull represented a lottery of good and bad work, with the tank's ultimate reliability dependent on which workers happened to assemble which components. The Americans observed heat treatment processes and realized with growing concern that Soviet furnaces lacked the thermostatic controls American factories considered essential. Workers estimated temperatures by color and experience rather than measuring with precision instruments. Sometimes they guessed right, sometimes they guessed wrong. The steel that resulted was inconsistent, varying in hardness even within a single plate. Machine tool maintenance shocked the American observers most profoundly. In Detroit, machine tools received scheduled maintenance whether they needed it or not. Preventive maintenance kept them accurate. In Tankergrad, machine tools ran until they broke, then received hurried repairs that restored function without restoring precision. A lathe that couldn't hold proper tolerance continued operating because stopping it would reduce production numbers. The parts it produced were out of specification, but they went into tanks anyway because meeting the quota mattered more than meeting the standard. One American engineer, watching a transmission assembly line, noticed that gears being installed clearly didn't mesh properly. He pointed this out to his Soviet counterpart, who shrugged and explained that perfect gear meshing wasn't possible with their current machinery. The gears would wear in during operation. If they wore too much, the transmission would fail, and the tank would receive a replacement transmission. This was acceptable because tanks typically didn't survive long enough for transmission failure to matter. The American engineer tried to explain that proper gear cutting would extend transmission life from perhaps 100 hours to perhaps 500 hours. His Soviet counterpart understood the mathematics, but pointed out that retooling to cut gears properly would halt production for weeks. In those weeks, the Red Army would receive no tanks. Better to send tanks with 100-hour transmissions than to send no tanks at all. This logic, ruthlessly pragmatic, mathematically defensible, industrially catastrophic, pervaded Soviet production. Every decision prioritized immediate output over long-term quality. The cumulative effect was an industrial system that produced impressive quantities of unreliable equipment. The Americans wrote careful reports recommending specific improvements: better machine tool maintenance, more rigorous quality control, improved worker training, statistical process control. Soviet officials thanked them politely and ignored the recommendations. Implementing them would require reducing production numbers temporarily, and reduced production numbers would trigger investigations by NKVD officials looking for sabotage. The political terror that Stalin's regime wielded wasn't merely background context. It was the mechanism that locked Soviet industry into its low-quality equilibrium. Factory managers who reported quality problems risked arrest. Quality control inspectors who rejected too many tanks risked accusation of deliberately undermining the war effort. Workers who pointed out design flaws risked being labeled wreckers or foreign agents. The safest course for everyone involved was to meet the quota, pass the tanks, and ignore problems that would become someone else's responsibility once the tanks left the factory. This systemic incentive structure made quality improvement nearly impossible, even when engineers understood exactly what needed fixing. Consider the air filter problem. Soviet engineers recognized early in the war that T-34 air filters allowed excessive dust penetration, causing premature engine wear. They designed improved filters. The improved design required slightly different manufacturing processes and marginally more expensive materials. Implementing the new filters across all production lines would have reduced monthly output by approximately 3% for 2 months during transition. 3% for 2 months. In exchange, engine life would improve by perhaps 50%. Over the course of the war, this trade would produce more operational tank hours, even though it produced fewer total tanks. The mathematics were clear. The proposal went to Moscow for approval. Stalin personally rejected it. The Red Army needed tanks now, not theoretical improvements in future reliability. Current filters were adequate, barely adequate, but adequate. Production would continue with existing specifications. The improved filters remained a paper proposal that engineering teams at multiple factories developed independently, submitted hopefully, and saw rejected repeatedly. This pattern repeated across hundreds of potential improvements. Better steel alloys that would require furnace modifications. Improved transmission designs that would require new tooling. Enhanced vision devices that would require optical manufacturing capabilities Soviet industry lacked. Each improvement was understood, designed, costed, proposed, and rejected, because implementation would reduce the monthly production statistics that Stalin scrutinized personally. The American visitors grasped this dynamic without Soviet officials explaining it explicitly. They recognized that Soviet industry operated under constraints American industry didn't face. The constraints weren't primarily technological or material. They were political and organizational. Soviet engineers knew how to build better tanks. They weren't permitted to do so. This realization informed American decisions about Lend-Lease. If Soviet industry couldn't produce quality equipment even when Soviet engineers understood quality requirements, then American aid should focus on providing finished goods rather than manufacturing equipment or technical assistance. Send tanks, not machine tools. Send trucks, not automotive factories. The Soviet system could absorb American products, but couldn't replicate American processes. The decision proved correct. Throughout the war, American equipment performed better in Soviet service than Soviet-built equivalents. Not because American designs were necessarily superior. The T-34's design was in many ways more advanced than the Sherman's, but because American production processes created reliable equipment, while Soviet production processes created unreliable equipment. Soviet tankers articulated this distinction with brutal clarity. A veteran interviewed decades after the war recalled, "The T-34 was a good tank when it worked. The problem was that it often didn't work. The transmission would fail, the engine would seize, the clutch would burn out, you would be advancing to battle and your tank would die, and you'd sit there while your comrades went forward without you. With the Emcher, you knew it would work. That certainty changed how you fought." The psychological impact of reliability extended beyond individual crews. Unit commanders planning operations had to account for mechanical attrition rates. A battalion of 30 T-34 seconds might have 20 operational at any given time, with 10 in maintenance or awaiting parts or simply broken. A battalion of 30 Shermans might have 28 operational, with 2 in routine maintenance. This 10-tank difference, 33% more operational availability, multiplied across dozens of battalions, produced strategic effects. Soviet offensive operations in 1944 and 45 achieved penetrations that earlier offensives had failed to sustain, partly because Sherman-equipped units maintained momentum. The tanks kept running. They didn't stop for transmission failures or seized engines. They pushed deeper into German rear areas because mechanical reliability enabled sustained operations that T-34-equipped units couldn't match. German intelligence officers noticed this pattern. Reports from late 1944 describe Soviet armored units displaying unusual operational persistence. German analysts initially attributed this to improved Soviet logistics. Closer examination revealed that units equipped with American tanks simply broke down less frequently. The operational availability rate was the difference. One German report, captured after the war, specifically noted, "American-built tanks in Soviet service demonstrate reliability characteristics markedly superior to Soviet production. Units equipped with these vehicles can sustain operations for longer periods without maintenance pauses. This operational persistence must be factored into defensive planning." The German army was acknowledging that American manufacturing quality was affecting battlefield outcomes in the East. Soviet quantity provided the mass necessary for breakthrough operations. American quality provided the reliability necessary to exploit breakthroughs before German forces could establish new defensive lines. This synergy, Soviet mass plus American reliability, created a combination more effective than either nation could have achieved independently. The Soviet Union couldn't produce enough reliable tanks. The United States couldn't deploy enough troops to the Eastern Front. Together, through Lend-Lease, they created armored formations that combined numerical superiority with mechanical reliability. Soviet leadership understood this, but couldn't acknowledge it publicly. Stalin's political legitimacy rested partly on claims of Soviet industrial might. Admitting that American factories produced better tanks than Soviet factories would undermine those claims. So the official narrative emphasized Soviet production numbers while minimizing American contributions. The engineers and officers who knew better maintained careful silence. Speaking honestly about American technical superiority was career-ending at best, life-threatening at worst. But they documented reality in technical reports, maintenance logs, after-action reviews. The paper trail existed in classified archives, inaccessible to historians but preserved for anyone with proper clearances. When the Soviet Union collapsed in 1991, these archives gradually became available to researchers. The documentary evidence confirmed what veterans had always known. Soviet tanks were mechanically unreliable compared to American equipment. Soviet production quality was inadequate compared to American standards, and Soviet industry couldn't close the gap despite understanding what needed to change. The numbers, laid bare in dusty files, were devastating. In 1943, at the Ural Tank Factory No. 183, average production time per T-34 was approximately 3,200 hours of labor. This represented a remarkable achievement. Production time had dropped from 9,000 hours in 1941. Soviet propaganda celebrated this efficiency improvement as proof of socialist industrial superiority, but context mattered. American factories produced Sherman tanks in approximately 1,800 hours of labor. The Soviet Union required almost twice as much labor to produce a tank that was less reliable than the American equivalent. Soviet efficiency improvements were real and impressive, but they were improving from a much lower baseline and never caught up to American standards. Part of the time difference reflected different production philosophies. American factories used extensive prefabrication, producing components in specialized facilities and assembling them on main production lines. Soviet factories, constrained by transportation bottlenecks, tried to manufacture everything in-house. This vertical integration reduced transportation requirements but sacrificed the efficiency gains that specialized production provided. American engine manufacturers like Ford or General Motors could achieve economies of scale, producing thousands of engines in dedicated factories optimized specifically for engine production. Soviet factories producing engines as one part of general tank manufacturing couldn't match this efficiency. The same pattern repeated across every major component. The irony was that Soviet industrial planners understood these principles. They'd learned them from Americans in the 1930s. But wartime conditions and Soviet infrastructure limitations prevented implementing them fully. The railroad system couldn't reliably transport components between specialized factories. Communication networks couldn't coordinate complex supply chains. So Soviet factories defaulted to vertical integration, accepting lower efficiency to ensure some level of production. American visitors noted another crucial difference: inventory management. American factories maintained carefully calculated buffer stocks of components. If one supplier experienced delays, assembly lines drew on buffer inventory and continued operating while problems were resolved. Soviet factories, lacking storage space and transportation capacity, operated on much smaller buffers. When suppliers experienced delays, a frequent occurrence, given wartime disruptions, assembly lines stopped. Stop and start production created cascading quality problems. Workers lost rhythm, partially. Assembled tanks sat idle, collecting dust and moisture. When production resumed, crews rushed to meet quotas, cutting corners to make up lost time. Quality suffered further. American continuous production maintained steady quality. Workers developed muscle memory. Processes remained consistent. Quality control could identify and correct deviations before they became systemic. The industrial system achieved stable equilibrium at high-quality standards. Soviet interrupted production never achieved stable equilibrium. Quality oscillated depending on current conditions. A good week might produce tanks that met specifications. A bad week might produce tanks that barely functioned. Averaging these variations produced the mediocre reliability that characterized Soviet equipment. Maintenance manuals reflected these differences starkly. American Sherman maintenance manuals assumed that routine preventive maintenance would keep tanks operational. The manuals specified service intervals: change oil every 50 hours, inspect tracks every 100 hours, replace filters every 150 hours. Following the schedule prevented failures. Soviet T-34 maintenance manuals focused heavily on troubleshooting and repair. The manuals assumed things would break and provided extensive instructions for fixing them in field conditions. Change a transmission. 12 pages of detailed instructions because crews would definitely need to change transmissions frequently. The manual implicitly acknowledged that Soviet tanks would fail and crews needed to be prepared. This difference in maintenance philosophy revealed deeper assumptions about reliability. American designers expected their tanks to work. Soviet designers expected their tanks to break. Both were correct. American tanks worked because American production processes built them correctly. Soviet tanks broke because Soviet production processes built them inadequately. Soviet tank crews became remarkably skilled at field repairs, or through sheer necessity. They could replace engines, transmissions, suspensions in conditions that would stymie American crews. This mechanical aptitude was impressive, but it represented adaptation to failure rather than triumph. If Soviet tanks had been reliable, crews wouldn't have needed to become expert mechanics. The resource costs of this unreliability were staggering. Soviet factories produced spare parts in vast quantities, more spare transmissions than tanks, because each tank would need multiple transmission replacements during its service life. Factories produced spare engines, spare suspensions, spare final drives, spare wheels. The industrial capacity devoted to spare parts production represented perhaps 30% of total tank production capacity. American factories produced far fewer spare parts relative to tank production because American tanks didn't consume spares as rapidly. The industrial capacity saved by building reliable tanks could be devoted to building more tanks or producing other equipment. This efficiency multiplier amplified America's already substantial industrial advantage. Consider the mathematics. If Soviet industry devoted 30% of capacity to spare parts and American industry devoted 10%, then the Soviets needed to build 15% more tanks to achieve equivalent operational readiness. The 49,000 American Shermans, backed by minimal spare parts production, provided operational capability equivalent to perhaps 60,000 Soviet tanks requiring extensive spare parts production. Soviet planners recognized this efficiency gap but couldn't close it. Improving reliability required quality improvements that reduced production numbers. Maintaining production numbers required accepting low quality that necessitated high spare parts production. Either choice consumed resources, but political pressure demanded maximum production numbers, regardless of efficiency implications. The waste extended to fuel consumption. Poorly manufactured engines ran inefficiently, consuming perhaps 15 to 20% more fuel per kilometre than properly manufactured engines. Over hundreds of thousands of operational hours, this inefficiency wasted millions of litres of diesel that itself required industrial production and transportation resources. Soviet fuel production was stretched thin, supporting mechanized operations across vast territories. American Lend-Lease provided petroleum products to supplement Soviet production, but those supplies went primarily to aviation. Tank forces drew on domestic production, which meant every litre wasted on inefficient engines was a litre unavailable for additional operations. American engineers who examined T-34 engines noted that combustion chamber machining was crude, leaving rough surfaces that promoted incomplete combustion. Properly machined combustion chambers would improve fuel efficiency by perhaps 10%. But proper machining required better machine tools and more skilled operators. Soviet factories had neither to spare. The cumulative effect of all these inefficiencies, low reliability, high spare parts consumption, poor fuel economy, excessive labor requirements meant that Soviet industrial output was perhaps 60% as effective as equivalent American output. The Soviet Union built more tanks, but each tank delivered less operational value. American tanks lasted longer, required less maintenance, used fuel more efficiently, and stayed operational at higher rates. This efficiency gap would have been less significant if Soviet industry had vastly exceeded American industry in absolute scale. But it didn't. By 1944, American industrial production matched or exceeded Soviet production across most categories. The combination of equal or superior production capacity plus 60% better efficiency per unit produced meant American industry was delivering roughly 1.6 times the operational capability that Soviet industry delivered. This multiplier explained why 4,000 Lend-Lease Shermans had strategic impact far beyond their 8% numerical contribution to Soviet tank forces. Those 4,000 tanks, reliable and efficient, provided operational capability equivalent to perhaps 6,000 T-34 seconds. The gap between American and Soviet production quality wasn't merely technical, it was strategic. Soviet generals understood this arithmetic. Requests for American equipment, especially tanks and trucks, came not from political pressure, but from operational commanders who'd experienced the reliability difference firsthand. Units lucky enough to receive Shermans fought harder to keep them than they fought to keep T-34 seconds. Losing a Sherman meant losing reliable capability that Soviet replacements couldn't match. This preference sometimes created awkward situations. Soviet propaganda emphasized T-34 superiority, but elite units preferentially, equipped with Shermans. Guards formations received the best equipment, and increasingly that meant American equipment. The political narrative and operational reality diverged visibly. Junior officers and ordinary soldiers noticed the contradiction. If Soviet equipment was superior, why did Guards units want American tanks? The question couldn't be asked openly, but it circulated in whispered conversations. Veterans interviewed decades later remembered the cognitive dissonance. We were told Soviet tanks were best, but the best units used American tanks. You didn't need to be smart to understand what that meant. The propaganda solution was to praise T-34 seconds while quietly distributing Shermans to units where reliability mattered most. Breakthrough formations, deep penetration units, forces tasked with rapid exploitation, these received American equipment. Defensive positions, secondary sectors, reserve formations, these received T-34 seconds. The distribution pattern revealed operational priorities, regardless of official statements. By mid-1945, some Soviet mechanized corps were equipped almost entirely with American vehicles. Tanks, trucks, jeeps, all American-built. These formations achieved operational results that purely Soviet-equipped formations couldn't match. They moved faster, maintained momentum longer, required fewer maintenance halts. They were, effectively, American mechanized units wearing Soviet uniforms and carrying Soviet flags. This dependency troubled Soviet leadership. Stalin personally worried about reliance on American equipment. His paranoia imagined scenarios where America might cut off supply to exert political pressure. His pragmatism recognized that Soviet industry couldn't yet match American production quality. The tension between political desire for independence and operational need for reliable equipment created policy incoherence. The solution Stalin eventually embraced was to accept American equipment while denying its importance, use Shermans in combat, praise T-34 seconds in propaganda, benefit from American reliability while claiming Soviet superiority, maintain political narrative regardless of operational reality. This doublethink characterized Soviet attitudes toward Lend-Lease generally. Accept massive American aid, 427,000 trucks, 13,000 tanks, 14,000 aircraft, billions of dollars of equipment, while claiming it represented merely marginal assistance to Soviet victory. Acknowledge American contributions in private, while minimizing them in public. The engineers at Tankograd occupied an especially uncomfortable position in this duplicity. They knew exactly how inferior Soviet production was. They'd measured the gap. They understood why it existed. They'd tried to fix it and been prevented by political constraints. Now they had to pretend the gap didn't exist while watching American equipment outperform Soviet equipment daily. Some maintained private notes, technical diaries documenting problems and solutions that couldn't be implemented. These documents, discovered decades later in personal archives, reveal sophisticated understanding of Soviet industry's limitations. The engineers knew what needed to change. They designed solutions. They calculated costs and benefits. They wrote proposals that political reality prevented from reaching implementation. One engineer's notebook, preserved in a Russian technical museum, contains a heartbreaking entry from November 1944. Today we received another shipment of American trucks. I examined the engine closely. The manufacturing precision is extraordinary. Every bearing, every gear, every seal, crafted to tolerances we cannot achieve. I understand how it is done. I know what machinery and skills are required. I have written reports explaining this. Nothing changes. We continue building inadequate equipment because the system cannot tolerate quality improvements that reduce quantity. History will judge us harshly. History's judgment has been mixed. Soviet propaganda succeeded in establishing T-34 mythology that persists. Popular histories still describe it as the war's best tank, crediting Soviet industrial genius for victory in the East. This narrative ignores documentary evidence of chronic reliability problems, quality control failures, and efficiency gaps. Academic historians, accessing Soviet archives after 1991, developed more nuanced assessments. The T-34 was an adequate design produced in vast numbers by an industrial system stretched beyond its capacity. It won through quantity, crew courage, and massive sacrifice, not through technical superiority or manufacturing excellence. The Sherman, conversely, has been judged too harshly by many historians who emphasize its limitations against German heavy tanks while ignoring its reliability advantages. The Sherman won through consistency. It worked. That reliability, boring and unglamorous, mattered more than armor thickness or gun penetration in determining operational outcomes. Soviet veterans who served in both tanks overwhelmingly preferred Shermans. Their testimony, collected in oral histories and memoirs, forms a chorus of praise for American reliability contrasted with frustration about Soviet mechanical problems. These first-hand accounts contradict official narratives but align perfectly with documentary evidence from maintenance logs and technical reports. The lesson transcends World War II specifically. Industrial culture, the accumulated practices, standards, expectations, and capabilities that determine production quality, cannot be copied or decreed into existence. It develops slowly through continuous refinement. Soviet industry tried to compress 50 years of American industrial development into 10 years of desperate effort. They achieved impressive results but couldn't close the fundamental gap. Modern manufacturing faces similar challenges. Developing economies trying to match advanced economy production quality discover that copying designs doesn't transfer manufacturing culture. Building a factory doesn't create the ecosystem of skilled workers, precision toolmakers, quality control systems, and management practices that enable consistently excellent production. The Soviet experience with tank production during World War II illustrates this lesson definitively. They understood the principles, they studied the examples, they tried to implement improvements, but they couldn't overcome the accumulated deficit of industrial culture development, quantity they could achieve through massive resource commitment and political pressure. Quality required what they lacked: the patient, incremental development of manufacturing excellence across entire industrial sectors. Tankograd's engineers never achieved what they attempted, not because they failed individually, but because they attempted something fundamentally impossible: creating American quality production without American industrial culture. That culture couldn't be copied, couldn't be imported, couldn't be forced into existence by quotas or political pressure. It could only be grown, slowly, through generations of workers and engineers learning standards and implementing improvements and building capability layer by patient layer. The Soviet Union eventually developed sophisticated industrial capabilities, but during World War II, facing existential threat, they couldn't wait for slow development. They built what they could build: vast numbers of adequate tanks that won through quantity despite mediocre quality. The engineers who built them understood the compromise. They documented it carefully, preserved the evidence, and waited for history to assess their impossible task fairly. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.